The stage is yours.
Great, thanks, Harsh. Hey, everyone. Let me share my screen, and we'll make a start. Okay, I think you can see that now, hopefully. Yeah. So, yeah, this is session 8. We've reached the end of the sessions. So this is, well, it was originally intended, I guess, just to be a review session, but I've kind of found lots of little bits and pieces that I thought it would be useful to slot in as well. And obviously there's quite a lot of news this time. So there's quite a few topics, as you can see, which I'll go through. I'm not sure how long it's going to take, but I'm sure we've got plenty of time. All right. So talk about the news. So I really like this this post from ZK George. Really sort of expressing the feeling I think a few of us have had, in that we've got loads of really exciting news all at once. Lots of important things happening. Obviously, the main thing being the mainnet upgrade being planned, but then also other pieces. So I'm going to go through all of those as well. But we'll start off with the upgrade. Obviously, we've been waiting for this for a long time, and we've been following the progress of the testing, etc. So it's great to get a confirmed date for this, which is June the 4th, which I think is a Tuesday. So yeah, really excited that that's been finalized now. I've got links there to a couple of posts about that, and I'm sure you know what the details are of what we're going to be seeing. Obviously, the main one is, I guess, the one that we're most interested in, I guess, is the first one, the fact that we're going to have our ZK apps available. But yeah, can't wait really. In terms of what to expect, there's obviously there's a link there to some documents about it, and then this diagram here to show what we should be seeing. Obviously, we've got to have a downtime. They say about 12 hours. So, yeah, I'm not sure which point we'll be having the parties, whether we're going to be celebrating at the end or all the way through. But yeah, we'll see about that. Yeah, so really great news. Looking forward to that immensely. Okay, and yeah, there's a countdown, as you can see here. So 38 days to go. Is that about? Yeah, that's probably about right. Yeah. So yeah, very exciting. Okay. Other things, other news, just about ZK MVP. That's now live for testing as well. There's an announcement about that. So yeah, you can read about that as well. Okay. Then other news. There's the hackathon in Krakow, which I forgot to put the date in there. I think it's something like the 17th of May, something like that. But you can find out about. I'll be there. I'll be hacking. So if any of you are going to be there, please do come say hello. I don't know what I'll be doing, whether I'll be developing on Mina or doing something else. I haven't really thought about it yet, but anyway, I'll be there, and it should be good fun. Hopefully, there'll be a few people writing ZK apps there as well. So yeah, as I say, please do come say hello if you're there. All right. So the other main thing that we had were changes to OpenJS. We also had a major release of that. I've got a link there to the change log, so that goes into a lot of detail about it, and there's the announcements as well. This is the announcement of it generally. This is the summary that from that. So removing a hashing bottleneck, I think is people are probably quite aware that hashing generally is a bottleneck, because we use structures that are so reliant on hashes, such as Merkle trees. So we're doing a lot of hashing, and hash functions are, generally speaking, quite computationally expensive, and often the hash functions themselves are not particularly ZK friendly, not easy to get into a circuit. So yeah, it's easy for them to become a bottleneck. So that makes a lot of sense. Performance on Apple Silicon, okay. Then obviously the asynchronous circuits, obviously that ties into the choice of the language we've got for our DSL. We've got TypeScript, JavaScript, so that makes a lot of sense. Recursion, well, we've spoken a lot about that anyway, so I probably don't have to say much about that. I will come back to this actually in a little bit later on and talk about recursion again. So, but yeah, obviously that's a main feature generally. And then, yeah, integration with UI makes a lot of sense. Okay. So let me turn then to another large announcement, which was the integration with Celestia. And this is all about data availability. And again, I'm going to come back to this a little bit more later on, and I talk about the kind of the general directions that blockchains are going in, and what we should expect. But this is really a part of the movement towards modular blockchains, the idea that blockchains have certain features, certain concerns that monolithic blockchains, the original layer ones, they would all do these different types of concerns. But then it was realized that perhaps it would be better if we could split this out and do this amongst a number of different chains. And so this is the idea behind data availability. And the reason we need data availability is the point that the participants in a blockchain, if I'm talking about blockchains generally, want to be able to verify what is happening on the chain. Obviously, that's a major role that they have, and that this is needed. We want to be able to verify. And in order to do that, we need the data to be able to reconstruct state. And there's a number of issues about this. Of if you're with a public blockchain and it's monolithic, then all of the state is there. So if you're running a node, then if you're a validator, then you will have access to all of the state anyway. So you have that. If you don't take that approach, though, if you start to move that, if you want to move that to another chain or have that held elsewhere in some way, then you get the problem with that data needs to be made available, and then you start to think of the sort of the economics and the incentive mechanisms and the game theory about how do you ensure that the data that is needed by validators will be available. And so what part of that is to have proofs of data being available, so that we don't have to necessarily get all of the data. We can have a proof that the data exists, and there are different ways to do that. You've got the example here where we can build in redundancy to our data, so that we can allow recovery even if part of it is missing. So this then will mitigate the effect of data not being available. So all of that then ties into the security that is there, because we're able to validate all parts of the state. So the announcement anyway was the idea that we would be able, or Mina will be able to use Celestia as a data availability layer. So Celestia generally that's the role of their chain, is to provide a data availability layer for different chains. And so we're able to do that, which means that that Mina can then be seen to be doing the other things that it does. So it can be providing the execution environment, etc. So that then takes load away from Mina. So that is a plus then for the network generally, and for scalability, etc. There's details about how this was done. If you follow this, there's a link here to a proposal around data availability, and then a number of different people were involved. And as I say here, along with Succinct Labs, there's a repo for this as well. It's a link to that if you're interested in details of how this happened. And then the nitty-gritty of this, how this has been built, is this this core contract, which will store commitments to data from the Celestia blocks, and then you can query details about this. And effectively, what you're doing is you're querying that it's effectively doing a membership proof. You're querying that some data is within a Merkle tree for a particular block range. So if you have the block height, you know a block range, and then you can query for particular data and get a proof that that data exists within the tree. This is also developed by geometry research as well, and the way that this was implemented was that we get Groth 16 proofs of the consensus. So this is the proof that this is the agreement of the state that is there in Celestia, that this is finalized, and then which we can get from the block headers and get proofs of that. So quite a complex thing being put together, but obviously the end result is going to be is going to allow better scalability, etc. Just to give you an idea of where this fits in generally, there's some details here about data availability, and there's a link there to documents from the Ethereum Foundation. If you're looking into data availability and looking at this, this has mainly been spoken of in terms of sort of layer 2 solutions and roll-ups, that kind of thing. And so some of this just gives you an idea of some of the terminology that is used with data availability for different types of roll-up systems. So you may see this if you're looking at roll-ups for the Ethereum blockchain. You'll see these types of terms being used. But yeah, we don't really go into much about those. Okay. All right. So I'll go on then to speak about something. So there was, someone suggested that I sort of add more details about this because it is quite a significant achievement. I had spoken a little bit about this a few sessions ago when there was an announcement about this. And I linked to a blog post about this, but I didn't really speak very much about it. So I wanted to go through it in a little bit more detail now, because it does open up quite a lot. And so I think it's useful for you to be aware of this and to understand how to do this, and really to understand what sort of types of things we will be able to do with foreign field arithmetic. So there's a link there to some docs, and really I've just taken details from those documents and taken examples from them as well. There's also a link there to the repo, so you can have a look at that. But the basic idea behind this is that when we build ZK systems, these are based, we're using elliptic curves, we're using finite fields, and really this, everything kind of is constrained by the fact that what we're doing is based on these finite fields. So these are made of a set of integers, and there is a maximum value of those integers. That's usually a prime, but as you'll see, we don't have to necessarily have that in this case. And so all of the arithmetic that we do is then affected by the fact that we are building on these finite fields, and our proofs are being built on these finite fields. And so the applications that we write, and when we're doing arithmetic, it really, to make it provable, it still has to rely upon these finite fields. And so you typically see this. I mean, you can see this across a wide range of different blockchains that are doing zero knowledge, by the fact that if you look at the DSLs, you see, and the data types that are available, you see that they are very much constrained by the finite fields that they are based on. And so, I mean, and this is, you will have been aware of this with Mina, and the fact that we are, the basic class that we have is the field class, and this is based on the finite field that we have. So that in itself, well, that's partly a restriction, I suppose, but there is the added problem that different blockchains and different types of proving systems will use different finite fields. They will use different elliptic curves, and the finite fields will be different. And so this causes friction. This causes problems if we're trying to integrate applications from one blockchain to another, and we're trying to use systems or algorithms from one chain, or one that has used one elliptic curve. If you try to use that on another system, then you can have problems because the finite fields don't match up. And so interacting directly is problematic. So what the work with this class that we have with foreign field allows us to do is to really extend what we have with our finite field, and this opens up then the possibility that we can interact more closely, more directly with other chains and with other algorithms and signature schemes, etc. So this potentially, is a very beneficial in terms of interoperability and how we can work with other blockchains. So yeah, for example, if you wanted to be able to verify a signature that was produced by a different blockchain or using a different signature scheme, then that might be possible by using the foreign field that are now available. And this article is, let me just check that link is okay. Yeah, so this was the original article I was saying, which spoke about the beginnings of this and what this allowed us to do. So this meant that we could, in addition to what we already have, we could also use the Ketchak hash function as well, which is widely used, and then the ECDSA, the signing algorithm that is used by Bitcoin and Ethereum, then also becomes available, which again is a great benefit because then we can use this to verify signatures, so, say a Bitcoin signature, something like that. So potentially this opens up quite a lot for us. So how do we actually use this? Well, we need the foreign field class, and to do that we have a class factory, and we use the create foreign field method there. And when we do that, we tell it what size of field we want to use by giving it the modulus of that field. So you're saying effectively what is the largest number within that field. When we're doing arithmetic and we're doing mod some value for that field, what is that modulus? And in this case, we don't, the modulus doesn't need to be a prime number, but the maximum that we can use with this is 259. So so that's effectively 2 to the 259, which gives us access to most of the elliptic curves. Most elliptic curves are built on finite fields, which are smaller than that. So this is it is a useful thing that we can do. So I'll just talk through then some examples from the documentation to show you how this is used. So This here is showing a how we create our foreign field. So in this case, we're going to use something mod 17. So we're creating our field 17, which is a field of mod 17, and then once you've done that, you can check that that's working. So you can create values from that, as you can see here, from a constant. You can assert then that that is equal to a particular value. So because we're doing mod 17, then 16 is going to be equal to -1 for that. And then you can also do various arithmetic operations as well, and we'll come on to which operations are possible in a little while. Okay. Now, a particularly useful size that we can choose is 256, or 2 to the 256, because then that matches up with what is available on Ethereum. So you can see here an example of that. So again, we just show the modulus we need for that, and then that creates the field for us. So again, just a couple of examples from that, and you can see that you can check that the values are equal there. Okay. So that's the basics of it, and that's the base type you would use. So you're using foreign field instead of field, and given that, then you have the sort of simple arithmetic operations that we generally want to use. So we can do addition, subtraction, negation, multiplication, division, and inverse as well. So those are all provided. You also get a couple of other methods that are it's not a couple, sorry, a few other methods, 4 other methods that are provable here. So we've got we can do an assert based on that the foreign field, and we can do a less than as well, and we can also convert this to some bits, and then convert back as well. So so those are all methods that are provable. So those would be they would be part of our circuit. But then there are also some that you can do that are not provable. So these would have to be outside the circuit. So you can see those examples there. So to begin. Now, having said that, the basic type then is the foreign field. We do actually that is actually split down into 3 types, and I think it's the case that if you're using this, that you will be guided anyway when you're using it into what is possible and what isn't. But I'll go through some details about that now. So the 3 types we have are the unreduced, the almost reduced, and the canonical, and these are available as the static methods on the field. So if you create a foreign field, then you can get those from static methods on the field itself. And the difference between the types I'll go through now. So for the unreduced, this means that, I guess this is the most loose in terms of what we are constraining. And it means that with this, it is possible that there could be a value larger than the modulus. And when we are doing arithmetic, this is the type of foreign field that we would get back. So you can see here that we've done some arithmetic on a foreign field, and then if you check the type that comes back for that, you can see it's an unreduced. It's unreduced type. So that's the kind of the loosest type of foreign field that we have. Then if we, oh sorry, the the unreduced then can be they can be added and subtracted, but they can't be multiplied or divided. If you want that, then you can use the almost reduced. So the reason that the unreduced, really, there, that's, you know, you're having fewer restrictions, but then that allows fewer things in a way. So this means that we couldn't safely do multiplication and division with those, whereas if we restrict it a little more, then we can do multiplication and division. So with the almost reduced, we can then do multiplication and division. So you can see there, well, you can check it out if you try to do that without on the wrong type of field. Yeah, so and you can see there, if you do the inverse, we get a reduced field as well. Now, it may be that when you're writing your app that you would want to restrict the type of foreign field that you are that is being used. If you're having something coming in as an input, then it maybe you would want to restrict that. And so this next piece of code here gives you an example of how you can do that. So you can see here we've got this we've created our class which is based upon a field that we've created, but we've based it on the almost reduced type of that field, and then that means that when we use that, as you can see here, we're creating some state based on that. Then that's going to enforce the type of the type that we can supply to this particular contract. So when you're adding state, it has to be of this almost reduced type, as you can see there. And then when you're so that's setting up the state. Then your method, when your parameter coming in here, will, that's going to be of that almost reduced type as well. So that's how you can do it. So it's really just extending the particular type from the field that you've already, from the foreign field that you've already created. Okay. Now the most restricted type that we have is the canonical type. So this with this we've got the most guarantees about what is happening with the numbers in that field. But this gives us the fewest operations then. So the only ones that we then have is this this equality check, as you can see here. Other things to note, with constants, they will always get fully reduced. So if you declare a constant, then that's going to be of the canonical type, as you can see there. So we've declared a constant, taken it from this numeric literal, and then you can see that it is of the canonical type. Yeah. Okay. And if you want to convert into the canonical type, you can also do that by doing the assert canonical. Oh, sorry, I've missed out my syntax highlighting there. But yeah, you can do that as well, as you can see. And there are different ways to do that, but an easy way to do that is to show that it's equal to a constant, as you've got there. Okay, so there are that's just really an introduction into foreign field and foreign field arithmetic. There's in the documentation there, you've got further tips about using that to help you with it. As I say, it's the reason that this is important and worth looking into is that it does open up the area of interoperability and allows us to work with data and signatures and algorithms, etc., that have come from other chains. So it is potentially it could be quite powerful in what it allows us to do. So it's really opening up the I was going to say the field. It's really opening up the area quite a lot, being able to do that. Okay. Now I just included as well this details here. There was a discussion on Discord about the BigInt implementation and what is possible with that. Obviously, BigInt is it's widely used in JavaScript, and so that's someone's been working on that to allow BigInts of up to 2 to the 256 using this foreign field arithmetic. So yeah, that's okay. Move on. So next thing I wanted to go through is just some useful things that have come up recently on Discord. So the questions that people have asked that maybe illustrate interesting areas, or maybe things that you won't have seen before. So I think they're worth sort of keeping track of. The one here, and actually I put this as a sort of question answer. I don't think I've sort of perhaps done this very well. So I think you're better looking at the post rather than just relying on this. But it will make more sense if you read the post and have a look at the context behind this. And this is really about the idea of I think this came from the idea of using nullifiers. And if I just to remind you, I did speak about the nullifier pattern generally, sort of in a quite early session, I think, and it's a pattern that is very widely used in zero knowledge systems. It's a very convenient pattern. It allows us to show that a particular resource has been consumed or a particular asset has been spent, and it is relatively easy to conceptually it is relatively easy to understand and potentially easy to implement. And I think this question was around the idea that if you have created a nullifier, can you then what's the best way? Sorry, with nullifiers, they're typically used by creating a nullifier and then adding a nullifier to some state somewhere, to typically to a Merkle tree. And so what you would do if you're trying to show that something hasn't already been spent was you would, when you do spend it the first time, you create a nullifier to indicate it's been spent. And then if someone tries to spend it again, then you'll go through the same deterministic process of creating the nullifier, but then you check within the Merkle tree whether that nullifier already exists. And so this question was about that really, and how, what is the best way that to implement this and to check that a nullifier doesn't already exist within a tree. And so the answer here is saying that the best way to do this is probably to use a Merkle map. And again, this is one of the common structures that is available for us to use. I'm sure you've used this or you're familiar with this already. But please have a look at that post. It will probably make a lot more sense to you if you read the post. Another question that I thought was interesting, an interesting use case, was somebody asking about whether it's possible to prove whether a contract has been deployed or not. And the answer, I think, is quite informative and worthwhile sort of thinking through. And it's the fact that it's the idea of a contract being deployed in itself is quite difficult to define, and it's not sort of something with a simple test for that. But what you should do is look at account updates and preconditions. And so what you would want to see is, if you think about an account and think about it being under a certain condition, then you can set a precondition for that. And then if you're thinking about something being deployed, and then that meaning that there is a verification key, then you can check for that, and you can prove then an account update with a corresponding proving key, if that verification key then exists for that specific account. So yeah, I hope that makes sense. But again, do have a look at the post. A simpler one is validating an address, generally a public key. So there's a piece of code there that should throw an exception if it's if the key itself is not valid. Another question about I guess about inclusion, but perhaps a simpler one, is looking at where there is an array and trying to prove that something exists within that array. And so the example that was given here was an array was created of a number of hashes, and they wanted then to be able to check later whether a particular hash exists within that array. And so this was a piece of code that would do that quite efficiently. So what you're doing is you're doing a map, checking against the particular one that you're interested in, and then reducing that with the OR operator to show that then that one of them then exists within that. Okay. So yeah, I think that's something that may be quite a common thing that people would want to do. So there's quite a neat solution to that there. Okay, and then so those were just some of them, just sort of everyday sort of questions that people have asked. And then this article here I thought was very useful. It's about ProtoKit, and we have, I mean, a couple of the challengers have used ProtoKit, and I've spoken about it quite a bit in the sessions. I think it's going to be very widely used. I think it's a very important project for Mina. And so this article is very good. It goes through a lot of useful information about the nuts and bolts, really, of getting ProtoKit running and sort of some of the common things that you may want to do with it. So here I think the example they've got is some kind of games they're going to run on it, but it shows you the types of things. If you want to set up a different sequencer, got details about that, details about the UI and logging as well. So showing you how you can convert your logging from provable types, etc. Reminder there, I did mention this, I think, but a reminder about some of the differences that we've got from O1.js, the fact that we have different asserts. I think they call these here the soft fail, because we want to be able to include things that have failed and still be able to assert. So we want to be able to assert things and have them fail, but then still be able to include those in the batch of transactions. So that's all about that. But yeah, lots of useful things there. If you're using ProtoKit, I would advise you have a look at that. And then also this repo as well is useful. Let me find this. Yeah. So they've got this. This is for games, but it does give a useful thing about some useful details about starting ProtoKit in a Docker container. So yeah, you can have a look at that as well. Okay. All right. Now, let's go on to something quite recent. So there was a ZK summit a couple of weeks ago, and then following on that, the next day there was a conference called ZK Accelerate, which had a number of talks, and one of those was from Brandon talking about, well, he was saying, what would we ideally want from a ZK platform? And then, at the end, he was saying, surprise, we've already got this. This is Mina. So I hope I didn't spoil the surprise there. But yes, it's an interesting talk and worth going through. But I wanted to take you through some aspects of this, because what I would like to do, for the rest of this talk as well, is to start to bring back some of the general ideas that we've thought about during these sessions, and some of the general concepts that are worthwhile thinking of and worthwhile focusing on, particularly when we're thinking about what types of things can we build on Mina, and what types of things should we build on Mina, and what is it, how are we making the most of the features of Mina? What is it that makes Mina special, and are we really building to those strengths? And so I think this is a very good talk, because it does go through some of these features and explain these quite nicely. So please do have a look and watch of the video. It's only about I think 15-20 minutes long. It's not a long talk, but it's it's well worth having a look at. It's got lots of pictures of sharks in it as well. He uses to illustrate his slides, but what he says, and when he's looking at what he thinks that an ideal ZK system should have, are these 5 properties, and if I go through these, or I'll go through most of these, I think this first one, this composability idea, I think this has really been shown to help development and adoption in the blockchain space generally. Certainly, we saw this with DeFi applications, and the fact that when people designed these, they built these in a way that made them composable, so that you could take an asset and effectively you sort of submit this asset to a number of applications or a number of contracts that you would sort of put together, you had composed together. And each of these applications, each of these contracts may have been, very simple. It may have been a very simple building block, but you put them all together, and then you could, supply some asset to those. And the end result of that is that you get something that is quite sophisticated and potentially quite novel. And so this is something that when you're designing an application, you want to be able to do, and that then depends upon your platform supporting this type of process. You want to make this as simple as possible for the app designers to be able to do. And so there's some features here that will aid that. And the first one, obviously, is a feature that we're going to come back to time and again, because it's really at the heart of what Mina is all about. Is the fact that we have recursion, but it's not just the fact that we've got recursion within the chain itself. It's the fact that the developers have access to that recursion. When we're writing our applications, we have easy access to this feature of recursion, and that's a great strength in Mina, the fact that we can easily do that. So that helps with composability. He gives an example in the talk of how you can build out effectively a tree, and within that, you can be going from one contract to the next and building out this tree of contracts. But also, there may be simpler things. There may be tokens involved there as well. You can compose all of these together into a a much richer data structure. He also recommends using familiar languages such as JavaScript, TypeScript, and then also the fact that to this we can add a ZK virtual machine. So we can do any type of computation within that, and do it in zero knowledge. Part of that, and part of the reason that we can do this and do it efficiently, is that, and that we can do it in zero knowledge, is that we can create proofs client side. We're not having to send off our witness somewhere else to create the proof. We can do that client side. That's important, and obviously, again, this is a great strength of Mina, and I think this has been borne out by the fact that we're seeing the idea of client-side computation. We're seeing this now in other applications, in other chains as well. I'm thinking particularly the way that Aztec has sort of pivoted and changed, what they're doing. They're trying to provide private state on Ethereum and private computation, but in order to do that, they're doing off-chain computation. They're doing client-side computation. So I think that is, that shows that this is going in the right direction. Obviously, one of the problems that you have when you're doing this is the potential for race conditions, where I spoke about this in session 1. Actually, we spoke about with the some of the solutions to this. We spoke about the sort of initial solutions, the sort of the action reducer idea, and then in later sessions we talked about other solutions such as ProtoKit. So yeah, so that's a recognized problem, but there are solutions to that, and I'm sure you're all very aware of those. Another point, and again, I've emphasized this, and I would really want to continue emphasizing this, that which is about decentralization. And again, this is an area where Mina really stands out in the fact that we can effectively and concretely achieve decentralization and involve people very widely in the ecosystem. And in order to do that, you need the ability to run on everyday hardware, to be able to run in the browser, to be able to run in phones, because people are not going to want to buy an expensive piece of hardware in order to run a node. That's going to be too high a barrier to entry. But if they've already got some hardware, if they've got everyday hardware already, and they can run a node in that, then that's much more feasible. The part of that also to help with that, we may need to simplify the computation we're doing. We may need to break things down into smaller steps, break transactions down, and that is certainly going to involve sequencing. And again, if we're doing that, we have to be wary of centralization. And if you look at the layer 2 solutions that we see operating at the moment, you will see that they use sequencers, and they're using centralized sequencers, but with the goal to move to decentralized sequencers. But it is always easier to start with something centralized. But we should always be trying to move to something decentralized with that. And I think the centralizing forces are always going to be a danger when we're developing blockchains, and it is something we need to be very aware of, and really to remember that the reason that we're doing this, and the reason that we've created blockchains in the first place, is to make something decentralized. And if we weren't going to do that, then we could have stayed in the Web 2 world and worked on centralized systems, and that would have been easier. But no, decentralization is extremely important, and so we do need to be aware of that, and then make sure the systems that we build can resist these centralizing forces. And certainly Mina does a great deal to help with that. And another point he makes about this is that when we're building these types of systems, we want them to be secure, we want them to be verifiable. And this idea of incremental verification, which is one of the approaches to I guess to sort of recursion, or well, a general concept, I suppose, in zero knowledge. Again, is something where Mina really stands out in the way that they've been able to do that. And what also is interesting is that then when you are creating proofs to prove the correctness of your system as a whole, then you may want to farm that out. Again, you don't want to be centralizing that system. You don't want to be sending everything to a centralized prover. You want to be able to decentralize that as well. And we've seen how we do this at the moment in Mina. We have the Snocket place where we're doing our snark jobs. So we already do this, but in time, we could go even further. In fact, I'm going to talk in a moment about this whole idea of proof marketplaces, because I think this is a very interesting topic, and one that you may well want to look into and may want to explore. And then Brandon goes on to talk about decentralization more generally, or to pick up some of those points, I suppose. And I suppose he's already spoken about some of these areas, but then the final one here, and I think he points out that this is not really addressed enough in blockchains. People tend not to think about this enough, although it is potentially an important thing. This potential bottleneck, a potential problem, is that the way the end user interacts with the system, we want to be sure that that isn't centralized either, that we have multiple points of interaction with the system. And this means that we have potentially many nodes available that people can use to interact. And again, this comes back to the point that if our system will run on everyday hardware, then this is going to make that process much easier to do. So these were the those were the points that he came up of the sort of desirable aspects, I think, that he was talking about that a system should have. And then he goes on to say, well, that we built this system, and he talks about Mina there. But it's an interesting talk, so please do have a look at that. Okay, so I said I wanted to talk about proof marks. This is just an example that I had some notes about, so I thought I'd share those with you, because I think this is, as a use case, there's a lot of scope here, and I think we're going to see a lot more in this area, and a lot more applications. And this could be, if you're thinking of things to build, this could be something worth looking at. So this particular one, I've got an example. Oh, I had been signed in. It looks like it's signed me. Let me sign in again. If you just bear with me, sorry about this. It must have timed out, I think. Okay, so I just wanted to show you this. I think this is not live at the moment, because I think this is showing historic. Yeah, it's showing historic data, but it gives you an idea anyway of what this type of thing looks like. And so this is looking at proofs for so this was proofs of the Mina state, which, if you remember, there's the Mina Ethereum bridge, which allowed us to post these proofs on Ethereum. So this is what this is about, and is showing details of the sort of a marketplace that you could have for that. And whoops, if I can scroll my screen, yeah, the idea here that you've got an order book where you could be doing this. So this is a marketplace for a number of different systems. This one is to do with looking for proof of a particular account, etc. But it gives you a general idea of the types of things that we could build with this. So I just wanted to share that with you. There's a little bit more detail there if you want to have a look at that. And there's some links there to the documentation and to some templates and a tool chain. If you want, I think the tool chain is if you want to be involved creating proofs, then you can use the tool chain to help you with that. Okay. So yeah, that's useful for you. I want to come back now to talk a little bit about a little bit more about recursion and an application. I don't think I really spoke about this. I concentrated more on ProtoKit, but this is another project that sort of has a similar role, I guess, or is in a similar area, in that it allows us to, if I can make this a little smaller, it allows us to batch together transactions. Sorry, there's a link there to the blog and details there in the repo. Yeah, I'll come back to that in a second. So again, this is similar idea. This is the idea that we can have a number of transactions that we will be able to submit, and then these can be batched together and updating some state, and we can be creating proofs of this as well. So just a couple of diagrams there to show you this the idea here that of being able to use recursion to sort of take in this batch and then recursively create proofs in a sort of a pairwise fashion here until you end up with a just one proof, general proof of the whole batch. So you're accumulating those there, and then those transactions then represent a state transition for the block, going from one state to the next. And the point about Hazook is that they've implemented this and sort of included the cloud computation aspect as well. So they're running this. It's based on, I guess it's a mixture of a kind of a zero knowledge layer 2 roll-up type of thing, plus Hadoop, which is a sort of Web 2 sort of cloud compute project. And they sort of combined this to allow this to handle many transactions. So here they got an example of 4,000 transactions. I think it's printed out slightly wrong badly here, sorry. It's but basically comes down to, I think, 6 cents per transaction. So all of these projects, one of the main things they try to do is to reduce costs, and they can do that by batching transactions together, and that can help. And an example they've got here of a good use case is to do with governance, where I think what they're trying to say here is that although the governance period itself would be quite long, and so you would have to have an application running for quite a long time, able to accept votes. The reality is that for most of that time, there would be very little happening. And then you would have a burst where there would be a huge amount of votes being cast, a huge amount of transactions that would need to be processed very quickly. And so something like this is then that will scale well, was then designed, will handle with that, that kind of sudden increase in load from the users. Yeah. So it's in some ways it's similar to ProtoKit. I think there's more of an emphasis on the sort of the load aspect, and that's the Hadoop aspect, I think, and what they've brought in for that, and the cloud compute aspect. So I think that's there's more there. Whereas with ProtoKit, you're not tied into a particular cloud infrastructure. You are very much doing it yourself. So that's a difference. If you want to sort of get involved in this, and if you want to use this with or use your applications on this, there are some points that you need to be aware of, which are given here. Some details of this given in the repo here, but you then need to have these two aspects here. So there's the base function and the merge function that you need to build into your application. And there's an example here. I think this is a kind of a template that you can use, where they've got, I guess, this the one step and the merge is there as well. Yeah, I think you have to do I'm guessing it's the one step part. You is one of the parts you need to own the merge there, that you need to implement yourself, or to make sure that your app will implement. Okay, so that's that. So that was a little bit more about recursion. Obviously, we've spoken about that quite a lot, and looked at some of these solutions that are available. Okay, so I want to go on now to talk really more about the general direction that we're heading in Web3, and to bring you some ideas of directions that we're going in. And again, hopefully, this is really just to maybe inspire you, or to give you ideas going forward when you're thinking about what you want to build. But I think one sort of large movement, excuse me, that we see in blockchains is this idea of modular blockchains. We've already spoken a little bit about this, talking about data availability, but I think this movement towards modular blockchains, I think, is going to continue. I can't really see this ending. I think this is just going to become, excuse me, more and more practical as time goes on, and we'll have more specialization between these different layers, between providing an execution layer, settlement and data availability, etc. And so you can see here we've got Celestia there for the data availability. So I think that's one direction that we're going to see generally. Of course, that means then that we're going to have these we're going to have much wider range of blockchains available, and that, I think, then ties in to the question of interoperability, and how are all of these different chains going to talk to each other, and not just the fact that where you've got something like, say, Optimism that is, or is really part of the Ethereum ecosystem and wants to speak to Ethereum, and then maybe Celestia as well. But also, how do these different chains speak to each other more generally, even if they're not necessarily part of the same ecosystem? And I think that is going to be there's a lot of potential there for work as well. And we've seen roll-up stacks coming about. This is just one example, the OP stack, where we've got these layers being created, or certainly in part, not necessarily all of these layers, but certainly some of them are created, and they're done in a way that can easily be we can easily spin these things up and create a chain that has these, and so you get this thing here. So I'm just taking the example of optimism here, an example of doing this. But they've got this idea that people would be able to spin up these specialized chains based upon one of these stacks, and then that will then tie in to maybe a layer one, as you can see there. But there's also this idea of some messaging protocol so that the chains can speak to each other. And again, I think that these cross-chain ideas, there's a lot of potential there as well. And if you then think back to what I was saying earlier about the foreign field arithmetic and the possibilities of that introduce, I think that's where you could see potential then for messaging between chains and doing something significant, passing data or assets between chains. And this sort of ties in another aspect of this, is the concept of the app chain. And really, ProtoKit, I think, is you could see that as being able to produce an app chain. And app chains are becoming quite widely understood, I suppose, so quite accepted as being a layer 3, perhaps an addition to a layer 2, or with ProtoKit, that's really potentially going straight to the layer 1. But the point of it is that we have specialized chains, though, because we can easily create a chain and we can customize it according to a particular type of application or a particular application itself. If we can do that easily and we can spin these things up, then we can do some very interesting things indeed, and it really reduces the time and work that is needed to create very efficient blockchains and that will be able to run specific applications. So there's a lot going on there also. It's also worth pointing out, though, that this ties into things that are already existing, but perhaps were not sort of seen as in the same way as part of that kind of roll-up architecture. But it's still worth bearing in mind that these are doing or fulfilling a similar purpose, and these are things such as the parachains from Polkadot, which all go back to Polkadot's main chain for security, but allow customization. Cosmos, of course, was built originally. The whole purpose of it was to provide interoperability, and the way that they do that is by the IBC protocol, which was designed to be as expressive and general as possible, so that any sort of blockchains will be able to interact and transfer assets. And so again, this is very much their bread and butter, I guess, being able to do that. But we also see with on chains like Avalanche as well, the fact that they have subnets where validators can come together to, sorry for the typo there, to build consensus on a particular chain. And they have specialized chains. They have an EVM compatible chain, etc. So these are examples of pretty much the same thing, even if they're not always sort of called the same thing. But it's worthwhile bearing in mind these things are very similar. But also, I think that there seems to be a lot of appetite to build these, and so this as a future direction, I think, is one worth bearing in mind. Okay. Now, I want to move on to an area that is quite, well, I find quite concerning, and this is around regulation, and particularly things that have been happening recently, and how regulation is impacting privacy, or how attempts to produce and to build and to use privacy preserving systems are being clamped down on really by governments and regulators. And particularly we're seeing this with financial applications. And so of course, the reason for this is that, the regulators see applications that allow you to do confidential token transfers, or where you can preserve privacy, as being something that can be used by money launderers, and therefore they're trying to block that route, I suppose. But that means that then they are trying to stop development of and excuse me, use of certain applications. And typically, or very famously, we saw Tornado Cash, and the whole. There's a big story about that I'm sure you're already aware of. But recently, there's a wallet, the Samurai wallet for Bitcoin, where the developers for that have been arrested. And I think one of the pertinent points about that was that they were they monetized the application. They were making profit out of this, and I think that was part of the reasoning that is being used, around the arrest, etc. But it is worrying that these types of things are being attacked, and are being targeted. And even there's an argument going on at the moment around MetaMask. So MetaMask built by Consensus, and the SEC are arguing about that and saying whether that should be regulated under the sort of traditional financial regulations, because it could be seen as being a broker. And then recently in the UK, there was legislation passed to allow seizure of crypto assets more easily. So we are seeing moves by regulators and governments against sort of privacy preserving applications. And I suppose what I want to say is here is that this I feel that this I understand some of the reasons behind this, but I also feel strongly that there is a need for privacy preserving applications. And so I would want to encourage people to continue to build these things, but also to make people aware that of the potential problems involved, and to encourage you to be careful when you're doing this. But it is certainly something that in a certain area that I think is needed, and that we should continue building in these areas. Okay, so carrying on, I wanted also to highlight this came out because of the work that was being done to integrate Mina and Celestia. It meant that so geometry research were involved in the work to do this, and it meant that they allowed verification of proofs which involved pairings within ZK apps, and they put out a post saying that now that we can do this, this opens up the area generally, and is showing some of the potential use cases here that you could do. Excuse me, such as building ZK bridges or roll-ups. Also different types of signature schemes, and being able to aggregate signatures. So again, emphasizing that we are making sort of technical progress, taking steps technically that are opening up the area and opening up the possibilities here. So as developers, I hope this would be encouraging, and you will see that there is this increases the scope of things that we can build there. Also just wanted to give you an idea of some of the research that has been happening lately as well. Obviously this is these are the papers I'm talking about, so they go into a lot of technical detail, but it also hopefully means these areas are going to then become available to developers, and will give techniques that developers can use. And this one is interesting in that they're bringing techniques, into circuits that make them handle certain operations more easily. As you can see here, things like equality of discrete logs, scalar multiplication, things like this that previously may have needed foreign field arithmetic, but now can be done more easily. So there's progress there. It's really, giving circuits the ability to do things more efficiently and cheaply, I guess. Another one here, this lattice fold is interesting because folding schemes have been very important over the last few years to help with the recursion within proofs. And this one here, the lattice fold, gives us this, but also gives us does it in a post-quantum way. So based on lattice cryptography, which is thought to be quantum secure, but it allows folding schemes to be based on that. So that could be very useful. And then this final paper I've got here is one, I think I may have mentioned it in the last session, but I was talking about security, and this is just a system of knowledge about that and about some of the vulnerabilities that there are in SNARKs. It also has some good diagrams and explanations about the SNARK process generally. So it's worth reading if you just as kind of general background about SNARKs. So yeah, so that's that one. Okay, so that's all of the new material, really. I just wanted to provide this as well, which is just a quick review. I've just listed out for the different sessions what topics were covered in that session. So if you want to go back and look through the notes, it will make it easier for you to find a particular topic if you're looking for one. I'll just quickly talk through the things that we covered. So we started off in session one, really was an introduction, looking at some of the common things that you will probably already have covered in 1JS. Things like some of the data types. I spoke a little bit about action and reducer because I wanted to introduce the concept of the problems that we have, the potential race conditions that could occur, and some of the solutions to that. And really that was to be used as a background when we later wanted to talk about things like protokit. I also spoke, and at the top there is really the most important topic from all of these sessions, and that is the idea of decentralization. And I keep coming back to this, and I make no apology about that, because that really is the thing that we should keep foremost in our minds, the fact that we are building decentralized systems. And this is really, the way that Mina has been built, this allows us to actually do that and to really resist the centralizing forces that some of the other blockchains are suffering from. In session two, we spoke about development in general and some useful techniques and some of the workflow and tools that are available. Session three, we moved on to recursion, which, not only is it at the heart of how Mina works as a blockchain, but because of the way that Mina has been architected, that then is available to us as developers, so that we can build recursive apps as well. And that is very useful. We spoke about, we also covered a little bit about ECDSA, which is going back to the foreign field idea. We then moved on to an aspect of application design that obviously is very important. With how are we going to store our state, and what can we do for that? And we spoke then, or came back to this idea of concurrency and the problems there, and the some of the alternatives we had. And then I then wanted to introduce some of the projects that help with this, and the idea of the layer 2 solutions that are starting to be built, and that's where we introduce these layer 2 projects. Session 5, I came back because I didn't really have time in session 4 to cover ProtoKit in enough detail, so I brought that back in session 5, and then also came back to decentralization. Session 6, we talked about ZK oracles, another great use case for Mina, and again, one that I think there's plenty of opportunity. And then also looked at some of the financial applications and decentralized exchanges and how they are being implemented. And then in the last session, we looked at a little bit of security and aspects around that and how we can ensure that. But we also covered a couple of other topics that I thought people would find useful, which were identity, and then also an up-and-coming area, which is integrating or doing machine learning in zero knowledge. And I think, again, there's plenty of scope here. It's a very new area, but there's lots of things to explore there. And I've certainly seen a few examples of projects coming through the cohorts where people have been trying to do this. Which brings us up to date and to the final session, which we've done today. So that's what we've done there. So to finish with, I just want to talk about some of the next steps. The Mina community is very strong, and I think it's I'm obviously aware of many other communities and amongst other chains, but I think it's fair to say the Mina community is really one of the friendliest ones I've come across, and one of the strongest and most supportive ones I've seen. I've been extremely impressed by it, and I just love working with the people in the Mina community. So it's which is a reflection of what all of you have been doing, but I think it's a great strength that is there to support you, to help you with the as you're building and going forward. There's some examples here of recent things that have been happening. If you look at this, if you look through the docs there, you'll see other ones, but some interesting things that people have produced from the community. But yeah, there's lots of other ones you can investigate there as well. And then obviously you're part of the Navigator program already, but there are other things that you can get involved with. There's documentation there about the grants program and what is available, in addition to Navigator and the ZK Ignite cohorts as well. There are also the grants available for the changes to the core, and you will get these requests for proposals as well. There was one that came up recently around tokenomics, so I've included that here as well if you want to have a look for that. But above all, for your next steps, I would say have a great celebration for the mainnet upgrade. Please keep building. You definitely are pioneers here, because we are about to take this amazing step when we are going to have all these applications available on Mina, and you are amongst the forefront of that. So please do be proud of yourselves for what you've done, and please do keep going and keep building and keep innovating in this area, and above all, please keep decentralizing through our systems, whether that's financial or other systems. But that's definitely needed. So I really do hope that you keep doing that and enjoy doing that, as I'm sure you will. So it really just we've come to the end of the time here. It just remains for me to say some thank yous. So obviously, thank you to Will and everyone at the Mina Foundation who were involved in all of the organization of this program and have done all the administration for that and have supported me in doing that. Thank you very much to everyone there. And of course, thank you to all of you navigators for everything you have been doing And yeah, I really do hope you keep going, and I wish you the best with all of the projects that you build. If you do end up going to the ZK Hack in Krakow, please do say hello. But also, I go to many conferences, so if you see me at any conferences, do please say hello. Do please say hello to me. There, it's always nice to meet people in person rather than over Google Meet. So I'll finish there and hand back. Just wish you the best of luck with all of your projects. And yeah, hope to see you at some point in the future. Thanks, everybody. Thank you.
All right. Thank you, Lawrence. And of course, a huge round of applause and thank you to you for organizing these sessions week on week, month after month. They have been a very valuable addition to navigators. It has helped them understand the details of the protocol. So very, a huge thank you to you, Lawrence. And I speak for all the navigators and everyone at Mina Foundation. And also thank you very much to all the navigators who have been watching this. And I will see you all in the next season. Thank you, guys.